Hello students, welcome to Solochem Lab. On the board is a problem, a 2022 UTME problem to be solved. The problem goes this way. Catalytic hydrogenation of benzene produces, and there are some options given to us. Which option is the correct option? In your SS1, you were introduced to this compound for the first time, benzene, when you were taught that covalent compounds dissolve in non-polar solvents like benzene. Do you remember the structure of benzene? Look at the structure of benzene on the board. It is a special ring compound. A ring compound is a compound that is not linear, not branched. The two ending atoms are connected. So it is like the regular ring we know. Do you understand? It's a cyclic compound, a special cyclic compound. Look at benzene here. Did you notice that the chemical formula of benzene is C6H6, and then the structure is what is on the board here. Each of the 6 carbon atoms has one hydrogen atom attached to it. Is that clear? And then this carbon atom here has carbon-carbon double bond, carbon-hydrogen single bond, and then carbon-carbon single bond, making the stable octet structure to be satisfied. Is that clear? Did you notice that if there's a double bond here, there won't be double bond here. The double bond appears again here and skips here, appears here. This is the structure of benzene. And when we say hydrogenation, it means we're adding hydrogen to this compound. Have you seen the hydrogen here? Hydrogen is a diatomic gas, represented as H2, a diatomic gas. And when you add hydrogen to this compound, do you know what is going to happen? The double bonds will be removed. The double bonds will go. Each of the double bonds will go. But the ring will not open. This is not it's not a ring opening reaction. Do you understand? Now, each carbon atom is going to get one more hydrogen atom. Already it has one. Each has one. But when we carry out this hydrogenation, each atom on the product side here gets one more hydrogen atom, as we can see. Do you see that this carbon that had the one hydrogen atom here now has 2 hydrogen atoms? That means we have added 6 extra hydrogen atoms to this compound that we started with. No double bond again. How then do we name this compound, this product here? It does not have double bond again. Check. Does it have any carbon-carbon double bond? Therefore, the correct name should be ANE ending. The suffix should be ANE. Do you know why it should be ANE? When you were introduced to hydrocarbons, you remember you were taught that when there are carbon-carbon single bonds all through, the compound is called a saturated compound. And when it's a saturated compound, the name ends with ANE. Do you understand? In this compound, the product, do you see any carbon-carbon double bond? No. Therefore, the name must end in an ANE ending. Do you understand? Why do we choose the word cyclo? Why is the word cyclo in the name of the compound? It is because this compound is a ring compound. It has a ring structure. That's why we put the name cyclo. Why is there hexane? Why do we say hex? How many carbon atoms are in this compound? 6. Yes, that's why we call it hexane. Do you understand? Okay. This compound is cyclohexane. Therefore, the correct option is option D. That's the correct option. You may also be asked, this reaction on the board, is it an addition reaction or a substitution reaction? You notice that atoms of hydrogen were added. They did not knock off other atoms that were there before. Therefore, it is an addition reaction. Do you understand? Take note. Benzene is a compound which can undergo both addition reaction and substitution reaction. But this example on the board is an example of where benzene undergoes addition reaction. And I've summarized it again down here, that benzene takes 3 moles of electrons, 3 moles of hydrogen please, to give us cyclohexane. You may also be asked, how many moles of hydrogen molecule are required for this complete catalytic hydrogenation? How many moles? From the balanced chemical equation, we see that we need 3 moles of hydrogen molecules. Is that clear? Do you have any question? Do not forget to drop the question at the comment area of this video so that in our subsequent classes, we'll look at the question. Thank you.